Have you ever wondered how the earliest galaxies were formed? This question has intrigued astronomers for generations. The launch of the James Webb Space Telescope has provided us with a unique tool to peer into the universe's distant past, allowing us to observe the cosmos in unprecedented detail. We are now able to journey back in time to the period when the earliest galaxies were taking shape. In our quest to understand these cosmic giants, we previously observed a correlation between the number of stars in a galaxy and the quantity of heavy elements it produced. The more stars a galaxy had, the more heavy elements it seemed to contain. This relationship appeared to be a fundamental aspect of galaxy formation and evolution. However, new observations of the earliest galaxies indicate that this correlation does not hold true for them. Intriguing, isn't it? You see, these galaxies are still in the process of being formed and have not had enough time to create heavy elements. This simple fact throws a wrench into the previously held belief that the number of stars in a galaxy directly correlates to the quantity of heavy elements it has produced. But new observations, thanks to the James Webb Space Telescope, are shattering this correlation. These early galaxies, still in their formative years, are showing us that the relationship between stellar mass and heavy elements is not quite as straightforward as we once thought. Theoretical models of galaxy formation have been hinting at this for some time, and now, finally, we have the observational evidence to back it up. These models predicted a discrepancy between the number of stars and the amount of heavy elements, a discrepancy that we are now observing in these early galaxies. These galaxies, still in their infancy, have significantly fewer heavy elements compared to their stellar masses and their star formation rates. This is in stark contrast to what we see in more mature galaxies, where there seems to be a balance between the mass of stars and the quantity of heavy elements. But why is this the case? Well, it's believed that these galaxies are being enriched with heavy elements at a slower rate due to the influx of fresh, unpolluted gas from the spaces between galaxies. This unpolluted gas dilutes the heavy elements, resulting in these galaxies having fewer heavy elements relative to their stellar masses and star formation rates. This challenges the current model of galaxy evolution, which assumes an equilibrium between stellar mass and heavy elements throughout most of the universe's history. Could these early galaxies be hinting at a shift in our understanding of galaxy evolution? This is a question that future observations with the James Webb Space Telescope will seek to answer. So, what's the explanation for this discrepancy, you might ask? Well, the authors of the study propose a fascinating theory. They suggest that these early galaxies are being enriched with heavy elements at a slower rate. This is not due to any lack on their part, but rather the result of an influx of fresh, unpolluted gas from between galaxies. This intergalactic gas, untouched by the stellar processes that produce heavy elements, dilutes the element-rich material within the galaxies, thereby slowing down their enrichment process. This proposal, if validated, has the potential to transform our understanding of galaxy formation. It introduces a dynamic aspect, emphasizing the role of the wider cosmic environment in shaping individual galaxies. It's a shift from the traditional thought that galaxies are largely self-contained entities, evolving according to their internal dynamics. And here's where the James Webb Space Telescope comes back into the picture. Its cutting-edge technology allows astronomers to observe the universe in unprecedented detail. It's expected to provide more insights into these early stages of galaxy formation, allowing us to test this new perspective and refine our understanding. This research then is not just about adding a footnote to our cosmic story, it's about rereading the entire book with a fresh pair of eyes and perhaps even rewriting some of the chapters. It's about acknowledging that our understanding of the universe is a work in progress, always open to new interpretations and revelations. This research has opened a new chapter in our understanding of the universe, prompting us to rethink our assumptions about the early stages of galaxy formation. These findings have far-reaching implications for our understanding of the universe. They challenge our earlier models of galaxy evolution, suggesting a more intricate relationship between stellar mass and heavy elements. The early galaxies, still in their formative years, appear to have been enriched with heavy elements at a slower pace, possibly due to an influx of fresh, unpolluted gas. This fresh perspective opens up new realms of exploration and understanding, promising more revelations about the early stages of galaxy formation with further observations to continuously be enlightened like and subscribe.